What if an aircraft could fly all the way across the world, remain almost completely invisible, and return home without ever being seen? It sounds like something straight out of a sci-fi movie, right? But this isn't some hypothetical scenario. It's a reality, and it's one that completely rewrote the rulebook of aerospace engineering.
Welcome to this explainer. Today, we're taking a close look at a machine that has absolutely captured the world's imagination for decades, the B-2 Spirit. This is an aircraft that didn't just push the envelope, it totally shredded it. We're going to break down exactly how this invisible bomber changed aviation history forever, using the historical and engineering data to really understand the magic behind it all. Okay, let's dive right into this. Section 1, the invisible aircraft, a landmark in aerospace engineering. So as you can see right here in the definition, the core concept we're dealing with is the flying wing design. When you look at the B-2, you know exactly what it is. It doesn't look anything like a standard jet. And this wildly unique shape, it wasn't just chosen to look futuristic or intimidating. It was actually developed with one primary, totally uncompromising goal: to drastically reduce how easily the aircraft can be detected by radar. By ditching the typical fuselage and tail sections, the parts that bounce radar waves right back to standard receivers, engineers created a shape that literally slips through the sky almost unnoticed. It's an absolutely brilliant marriage of form and function.
Moving on to Section 2, Cold War Origins, an era of rapid innovation.
Now, it's super important to remember that this marvel didn't just happen in a vacuum. The development of the B-2 kicked off during the Cold War. That was a period defined by intense, high-stakes global competition, which naturally drove an era of rapid, almost frantic technological advancement. Nations were pouring incredibly heavy investments into research and innovation. To actually make the B-2 a reality, engineers couldn't just grab off-the-shelf parts. They literally had to explore entirely new materials that could absorb radar rather than reflect it. They had to develop highly advanced computer-assisted flight controls from scratch. And of course, they had to embrace totally unconventional aircraft designs that had rarely, if ever, been attempted before. The pressure was definitely on, and that pressure cooked up some of the most cutting-edge science of the 20th century.
Which brings us to Section 3, Defying Traditional Aerodynamics, Engineering the Impossible.
Okay, to truly understand why the B-2 is such a marvel, we really have to look at how it actually flies. Looking at the comparison here, on the left, we've got traditional airplanes. Pretty much since the dawn of flight, traditional planes have relied on a tail section for aerodynamic stability. If the wind gusts or the plane banks, that tail physically helps keep the nose pointing in the right direction. But on the right, we have the B-2 Spirit. Because slapping a tail on it would completely ruin its radar and visibility, it just doesn't have one. Now, inherently, a flying wing is incredibly unstable in the air. So how on earth does it stay up? Well, it relies entirely on incredibly sophisticated flight control computers to remain stable. These computers are constantly making microscopic adjustments to the wing surfaces, literally every single second, just to keep the aircraft flying straight and level. It's wild.
So, the crucial point here is that the B-2 proved physical aerodynamic limitations could actually be overcome. It pushed the limits of aviation by having software and physical design work perfectly together. The physical design of this plane literally requires the software just to keep it in the air. It showed the whole world how advanced software and radical physical design could sync up perfectly in absolute harmony. Basically, if the computers failed, the physical shape cannot fly on its own. That level of integration was a total game changer.
Let's look at Section 4, the price of innovation, cost, complexity, and logistics.
Obviously, overcoming all these impossible hurdles came at an immense cost. The sheer scale of this project was just monumental. First, it started with this radical design conception, right? But that idea quickly gave way to step 2, years of grueling development and extensive testing. Because of the aircraft's staggering complexity, you couldn't just slap a prototype together and take it for a spin. Every single thing had to be tested, retested, and perfected. And that massive testing effort seamlessly led into step 3, highly advanced manufacturing and precision. The precision required to build a B-2 is just mind-boggling. I'm talking exterior panels that had to fit together so flawlessly that there were zero gaps or seams for enemy radar to catch. This incredible complexity meant each individual B-2 required an immense amount of time and resources, making it one of the most expensive aircraft programs in human history.
But all that immense cost actually bought something completely unprecedented. Beyond just the stealth tech, the B-2 completely changed how the world viewed long-range aviation. Take a look at this key capability, global reach. We are talking about the ability to travel extraordinary distances without frequent refueling. It really showcased the ultimate importance of logistics, meticulous mission planning, and top-tier engineering excellence. It literally meant this aircraft could take off from its home base, fly all the way across the globe, complete its objective, and return home, all in a single, incredibly long, continuous flight. Just wow. Finally, we land on Section 5, an aerospace icon, a legacy of progress.
Bringing things into the present day, the B-2's impact ripples way, way beyond its military origins. It is an absolute triumph of scientific research. Today, it's a major focal point for so many different groups. We've got aviation museums preserving its history, historians analyzing its immense geopolitical weight, and of course, modern engineers and students who continuously study it. They're still looking at its airframe, its advanced materials, and its flight systems as foundational milestones in aerospace. It represents decades of pure scientific research and engineering creativity that is honestly still super relevant today.
And this brilliantly illustrates our core takeaway. Some aircraft become famous just because of their raw speed, but others become legendary because they are redefining what engineers believed was possible, and that is exactly what the B-2 Spirit did. It took the old rulebook of aviation, tossed it completely out the window, and wrote a brand new one. It proved that, with enough ingenuity, the seemingly impossible could actually take flight.
So, as we wrap up this explainer, I really want to leave you with a provocative thought to ponder. The B-2 Spirit continues to inspire so much curiosity and innovation. So, looking at the incredible leaps made to get this flying wing into the sky, how will the curiosity and innovation inspired by the B-2 Spirit shape the very future of flight? What impossible concepts are engineers working on right this second, using the lessons we learned from this exact aircraft?
When we look back at the Invisible Bomber, we aren't just looking at a cool airplane. We are looking at a true testament to human ingenuity, because ultimately, innovation shapes history. Thank you so much for joining me for this explainer, and keep staying curious.